All right, so today for the Global Happy Hour, we have Chris Sundberg, and he is going to talk to us today about cybersecurity. He's worked in wireless communication for the past 30 years and embedded system development and that type of thing. And it's really just super to have you on with us today, Chris, because I think it's kind of top of mind for a lot of small businesses. They're like, am I good enough, or is this close enough?
And Ken, you're definitely right. And even with today, some late breaking news I did make in the presentation, there was a national security memo issued by the White House on industrial control systems and critical infrastructure. And we're actually going to be talking a little bit about that today with the products that I produce and kind of security around those assets and items.
Excellent. So I'm going to kind of let you take it away. I've given you sharing rights, and so hopefully you can...
Okay, let me... Yeah, there we go. Continue.
There we go. We see it. So.
All right. You can see it. So the presentation should be up. Yeah, so what we're going to talk about today is really around industrial security and industrial control systems, or ICS. And it's really around security issues that are on the operational side. So again, Ken, thanks for inviting me in, and then looking forward to speaking to the Global Chamber. A little bit of background about myself. My name is Christopher Sundberg. I am a certified GICSP, which is a Global Industrial Control Systems Security Professional. It's a GIAC certification. I work for a company called Woodward Incorporated. For some of you old timers out there, we were known as Woodward Governor, but then we dropped the governor when no one really realized what a governor was, other than a political figurehead. But we still make them. I am the product cybersecurity engineer. So what that role is, I'm in our corporate technology department, not our IT security department. But our corporate technology department, I oversee the architecture requirements, all items kind of around product security for the systems we produce. And we'll go over what kind of systems we actually produce at Woodward and how security impacts those in the next slide. As we kind of said, I've been programming for about 25 years, going on 30 years now, in various software aspects. I started off in actual language translation, going from English to different languages for user interfaces, branched into wireless programming for law enforcement software, and then moved into embedded systems in kind of the most recent iteration of my role. For about the last 15 years, I've been working in cyber physical system security, and we'll get into what cyber physical definitely means. I am sitting on the SAE, the Society of Automotive Engineers G32 Cyber Physical Systems Security Committee. It's a group that's being put together that's putting together standards around cyber physical systems that are used in industrial, automotive, military type components. And we've really kind of been pushing that quite a bit recently, just because of all the different attacks that have been in the news. On my Twitter handle, if you want to reach out to me, I'm at Sundbug272. And my LinkedIn handle is Chris Sundberg. And I'm sure there's a lot of Chris Sundbergs out there. So I did put my LinkedIn picture on there just so you recognize me. Maybe. There we go. So where do I work? Well, Woodward is a 150-year-old company. We're headquartered in Fort Collins, Colorado, but we really have a global footprint across the world with different production and design areas. We basically supply cyber physical systems or embedded control type devices, valves and actuators in several different markets, industrial, engine systems, and in aerospace. So for some of our industrial controls we have out there, these are kind of examples of the devices we put on. They sit usually in a plant, a place where you require protection and stuff like that. These are valve drivers that handle valve actuation in very harsh environments. We also make a wide variety of controls. So these are industrial controls that actually control prime movers or sequence sequence devices like engines, turbines, that type of stuff. We also have some power synchronization tools that are out there for standby generators, those types of things. We also have engine system controls, which actually go on highway and automotive vehicles that provide logic for controlling those platforms. And finally, we have aircraft actuation and aircraft electronics, and these are really what you put on aircraft to move surfaces like ailerons or control different aspects of flight. So that being said, the agenda we're going to go over today, really, we're going to touch on some recent security incidents that have been in the news. What's different in industrial control systems, or ICS. We're going to look at some of those threats. We're going to look at how to secure ICS, both through network security and through the supply chain. And then finally, we're going to have questions. And I really encourage you, if you have questions during the presentation, chime in, ask them. This is a very interactive presentation. It doesn't hurt to, it's a very complex topic, so it's a lot of fire hose type things. But definitely, I can field whatever questions you guys have. So some of the recent incidents have been in the news, and this is kind of a mix of a bunch of different issues. But in July, we had that Kaseya VSA supply chain incident, and we're going to talk about that kind of towards the tail end of the presentation. But that's one example of something that may impact a cyber physical system. We have Colonial pipeline that happened back in May 2021, and while that's not a direct attack on an industrial control system, there are some different hooks in there that actually impacted delivery of product. Way back in February of this year, I know this year's kind of flown by already, the Oldsmar water incident, which was an incident with a water treatment plant in Oldsmar, Florida, where someone was able to get in and adjust some settings. Unfortunately, there was an operator there that caught them before any damage could be really performed on the water system. But it has really sparked a lot of legislation that we're kind of seeing today work its way through.
On that one, what were they attempting to do? Were they just messing with the parameters, or did they actually
they were actually
know what they were doing?
We think they may have known what they were trying to do, but they didn't realize that there were some safety aspects of that system that would prevent them from doing it. And what they were trying to do was adjust the lye concentration through an HMI. So what they were able to do is they were able to get into the industrial control system through what's called a remote access point or virtual private network, using a known username password combination. They're able to get over and see the HMI using a program called TeamViewer, which is a remote access application. They adjusted the lye settings, and fortunately, there's kind of a safety system backup in there that prevents from flooding. It only allows you to adjust the lye settings in so many increments to prevent poisoning and stuff like that. And someone was able to catch it. So that's what they were trying to do. I don't believe there's been any formal attribution as to actually who was trying to do it. We just know a lot of the details around it. Good question. Along similar lines was the Ukraine power grid hack from back in 2015 and 2016. And similarly, someone was able to get into through remote access, through remote view, and start working with a power grid HMI, or human machine interface. What ended up happening was an operator was there, saw a mouse moving, and there was no one else in the building, and said someone was trying to take down the power grid. They were partially successful. They did what was called a watering hole attack, where firmware was downloaded that had malicious capabilities in it, and basically wiped a bunch of serial to Ethernet or some devices that you could send commands to for in remote substations and stuff like that. They also wiped or erased the firmware and software for the uninterruptible power supply. So when everything went down, the uninterruptible power supply has lost logic or didn't know what to do and wouldn't turn on to repower the system. It impacted about 226,000 utility users or so back in 2015 around Christmas time. And then there was, again, kind of a lot of a lot of attention that Department of Homeland Security and CISA kind of put towards this power grid hack to secure our electrical systems. About a year later, they tried to do the same thing again and had more limited success. One of the interesting things about the power grid hack and how Ukraine recovered from it, they still had a lot of manual backup capability in that in their power grid. So they actually drove out to each substation and were able to restore the grid in kind of a normal amount of time. So the other ones are common, or you may have heard of Stuxnet. That was a subject of a book by Kim Zetter called Countdown to Zero Day. It was also the subject of a documentary of the same name, but that was basically malware that was implanted in an Iranian nuclear facility to spin up the centrifuges so they would fail more rapidly. So that's kind of the most classic example. And in my line of work, we usually have the Stuxnet war clock. Whenever it's mentioned in a talk, we have to reset the timer to 0. So I took care of that for this month, at the end of the month. Triton Traces, this was actually an impact of what's called a safety system. So in industrial control systems, we're controlling a process, and oftentimes we have a safety system that's backing up and making sure that process is running within normal parameters. In this case, we had a malware that was implanted in a petroleum installation in the Middle East, and it was actually impacting the safety process. There were some backup systems that prevented anything drastic from happening, but it caused a lot of consternation in security researchers about how this could exactly happen, because these are typically not connected to the internet. And it turned out that there was a software download to read user logs or event logs from controls that was actually acting as malware and impacted these the Triton Traces controls that they were targeting. And finally, Norsk Hydro. This is an aluminum manufacturer from Norway. They were impacted by ransomware actually on their ICS side that brought down their production and operation side way back in 2019. So right before the pandemic, this hit, and they were fairly transparent about how they recovered and exactly what that impact was. So those are just high-level incidents. There's tons of incidents happening every day, but these are really kind of the big ones that may stick in people's minds around cybersecurity.
Yeah, so we hear a lot about ransomware and that
Yep.
sort of thing. The attacks, the majority of the attacks that you're talking about here are not necessarily ransomware attacks, right? These are
correct. Yep, these with the exception of the Colonial pipeline and Kaseya VSA, every one of those took place on what was called the Industrial Control System Network. And I'll get into that architecture, Ken, about exactly where that line is and what made Colonial pipeline a little bit different.
Okay.
Cool. Any other questions? Awesome.
All right, Chris, one question quick.
Yeah, go.
On
Yep.
Triton, I know a little bit about that, but I think that was a Russian hack, wasn't it? Maybe not, but
Yes,
I know it was more or less a terrorist attack.
The threat group was attributed to a Russian threat group, or advanced persistent threat group. They're called APTs. But yeah, that was attributed to that group. Yep.
Any of these, I know that one, I mean, the outcome could have been loss of life, but I mean, any of the rest of these, I mean, what were the motives behind them?
Usually it was hacktivism. Hacktivism. Maybe they had a beef with the company. Nothing really nation state here on the industrial control side, other than that Ukraine power grid hack, which was again attributed to Russia and actually was quite extensive to see what could be done. Sometimes it's ransomware as a service or a threat actor as a service, where they're hired by a nation state or a political organization to cause damage to a particular target. I know in the Mideast environment, you've got a lot of players in there. You've got Israel, you've got Iran. They're both targeting everyone else, and then you have everyone in the Middle East kind of caught in the middle. Saudi Aramco is probably a great target that constantly gets hit by Iranian hackers using a variety of tools like wipers and stuff like that. Usually on the IT side, it's business disruption, loss of financial life or loss of financial value, loss of making money, that type of stuff.
Yeah.
When you start getting into the process side in industrial control systems, which we'll get into, that's more of a that's where we get into the kinetic effect, where we have the potential to go boom, you know, possibly with loss of life and that kind of stuff. And a lot of times in those, like I said, in those systems, you have those safety systems to make sure you have the checks and balances in place, and that's really kind of an ultimate target everyone wants to get into is hey, how do we manipulate those safety systems to go a little bit off keister and actually cause an event to happen? Good
Sure.
question.
Thank you.
So here's kind of a interesting graphic that came out in when Oldsmar actually hit. And if you look at this, these are some of the other attacks that have happened. You can kind of see the Ukraine 2016 power outages. Over here, the unspecified German facility, that was actually a German steel mill whose furnace kind of went uncontrolled and is considered a cyber incident. And then, of course, Stuxnet, which is probably the most visible version of it. But over here, you've got this, what we call the ICS kill chain. There's stage one, and it's kind of the cyber kill chain as well, but we're doing, reconnaissance. We're not doing really anything bad. We're mostly doing data exfiltration to get more information out so we can develop better stage two exploits, which you kind of see over here, which actually impact the cyber physical systems. Oldsmar was really kind of a low level exploit because they used TeamViewer, remote access with a known username password, and were able to just manipulate values. So it relatively speaking, it's kind of low on the list. It ranks right up there with the New York dam intrusion, which was kind of interesting because Iranian hackers found a dam control device or a valve control device out on the internet, tried using it, but that dam control device was actually out for repair, and they were manipulating it on the test bench. So if it would have been hooked up to a dam, they were trying to actually cause damage. So that's kind of an example of where Oldsmar fit and where other common attacks in the past have happened. So, kind of taking a step back about, security and OT type security, there's this concept of a network triad triangle where we have confidentiality, integrity, and availability. And any security program dealing with information technology networks are usually concentrating on these three aspects of information that flow across our networks. So this is kind of the basic network tenet. It's what I like to call the fire triangle of information, because you have air, fuel, and heat, and confidentiality, integrity, and availability are kind of their own many versions of that. And all three of them make up information, and information flows. However, like when we start talking about information technology and enterprise and office networking, that's really kind of that front office. That's the kind of information that we use in day-to-day business: email, business systems, ERPs, file storages. They're really concentrating on information security. So their big item here is confidentiality and integrity. They want to make sure that information is secure. It came from a known source. It is what it says it is. In here, a lot of the security solutions are mature. You have a lot of security service solutions, security operations centers, intrusion detection, managed service providers. These are the guys that, they can put a sensor on your network, figure out what or indicators of compromise of vulnerabilities and attacks are happening, and everything's really resilient to that kind of network traffic or that kind of security system. We start talking about the back end, we're really talking about the production floor. We're talking about outback. We're talking about personal protection equipment required. Of course, if I would have said this in 2020, I probably would have left off that last one because everyone had personal protection equipment with masks and everything like that. But we're talking hard hats, gloves, heavy boots. So In operational technology, a lot of times these are custom systems that have been developed to drive a specific process. These custom systems are very expensive. They're part of capital expenditures. They usually have low resources, meaning that their processor, their memory, that type of stuff are very low powered, minimally powered to, one, not produce a lot of heat, but also be kind of the cheapest equipment you can make that's still reliable. It also runs typically what's called an RTOS, a real-time operating system. So that's an operating system that's very heavily into the timing of when things happen. So if you look at your Windows operating systems or your Mac operating systems, those are what are called general purpose operating systems and are more where we call event-based. So things happen, they respond to events, or they run a program. You click on a mouse or you drag and drop a file. Real-time operating system is what we call deterministic. So it's very finely tuned as far as how many milliseconds it's going to take to run a particular task or a function. And it could also be event-driven based on an encoder wheel or some cyber physical means. So that's kind of the big difference between what you find in IT, what you find in on the shop floor. Back in the production floor, we're really looking at availability as being king. We need that data to be flowing to make sure the processes are happening and happening correctly. And integrity, confidentiality kind of take a back seat to that. Integrity, not so much. You may want to know where it's coming from, but if it's not available, if you're not getting that data, that process pretty much stops. Security solutions in the last couple of years have migrated from information technology into this area, but not all solutions or practices from IT work well in this area. As our old friend Marco Ramius would probably say to Jack Ryan on board the Red October, be careful what you scan. Most things in here don't react too well to active scanners. Which means if you're actually actively scanning for a threat, for a vulnerability, a lot of the controls that are in an operational technology environment cannot withstand those scans and will fail, or you'll have to do a power reset. So not all IT solutions can really work. You can use what's called passive scanning, which is you hook up a network connection to like what's called a router or switch to monitor network traffic, and you can get data off that, but it's also only when traffic's actually flowing are you going to see some of that data. So common reference here in industrial control systems, we use what's called the Purdue model. So that Purdue model it's a 5-layer model that was developed by people at the university or Purdue University around how to describe kind of the modern production network architecture. So information technology, what we just kind of described, is really up here in the level 5, level 4, and kind of partially in the level 3 area. So level 5, 4, and 3 are really your business systems, your front office type systems, things that you're going to use for dashboards or KPIs around your production area. When we start getting into the industrial control network, it's really down from level 3, 2, and 1, and 0. And these are where we have control systems, cells, manufacturing cells, I should say, processes, human machine interfaces, which are kind of the fishbowl in these areas that we have to secure. When we're down here at the very low level, which is level 0, level 1, there's really no network interfaces that are present. These are directly connected to cyber physical systems. So down here, you're really controlling that the physical process through program controls or through sensors and actuation. When we get up to like level 1 and level 2, we might see a little bit of networking connectivity, but again, these are very far back inside the relative network. So I like to call it the tail end of the SCADA. Typically these items aren't very routable. They're very custom programmed. They're expensive because they're usually controlling some expensive machines.
So at that level, at level 2 at least, you're seeing OEMs or manufacturers of these products who are wanting to have access at that level, correct? I mean, they're starting to want to be able to get into that level and to be able to fix issues, when they occur. So how does that play into all of this?
So that's kind of that remote access aspect of it. And I'm glad you mentioned that, because the Purdue model starts getting broken when we start talking about industrial Internet of Things, IoT, analytics and sensor type stuff. And this down here is kind of the data field that industrial control systems can provide for IoT and applications. On the remote access side, it's kind of, you get what you pay for. So, or you get what you pay for, you get what you architect. If you just want simple, if you're a small OT company, you want simple connectivity, you can stand up a VPN server, you can stand up some remote access and put it in place and have access to kind of everything down here. But you take a risk as far as, do you have any strong username password authentication, two-factor authentication? What access do they exactly have? A lot of people don't consider it. They just say, I just want a view into my human machine interface or my Windows box, troubleshoot some stuff, and then I'll be back out. And 90% of the time that's okay. But if you're a target of an attacker, they're going to use that as an access point to get back into those control systems. If you're, depending on how secure you are and in your regulatory environment, you may have to put in additional security around your remote access, like specific users, specific groups that have remote access, as well as concepts of like jump servers, access control lists, that type of stuff. This is one of those areas that it's fairly well understood how an attacker can get in, fairly well understood how to protect it, but not everyone has the resources to do that protection.
What's a jump? Just quickly, what's a jump server?
Oh, sure.
Sorry.
So instead of having like a direct remote connection to like an HMI system or a PLC or a server, you actually have access to this, I want to call it a intermediate box, an intermediate computer called the jump server. And basically, your only remote access is into that jump server, and that jump server then can provide you access, through different authenticated means to the local HMI and to the local PLC or devices on the network. So that if the jump server gets the jump server is kind of the sacrificial lamb, if you will. If that gets compromised, it can easily be shut down without impacting a lot of the other processes. Plus, you can only, if depending on what kind of controls you have, you can put scanning or what we like to call sheep dip stations on the on that jump server to make sure any software you're trying to upload or manipulate is actually passes inspection, doesn't have any malware on it. Does that make sense?
Yeah, that makes a lot of sense. I totally get it.
And it's real. Jump servers are relatively cheap protection too,
right.
When properly implemented. So they're handy to have around.
Right.
Any other questions on the Purdue model?
So just about the jump server. So is that sort of like a buffer zone?
Yes. Yep. Right. It definitely, that's what it is a buffer zone. So if, let's say you had a remote access appliance, a VPN appliance that had a vulnerability on it. Someone took advantage of it. They were able to get into your system. And the only thing that VPN appliance was connected to on your network was the jump server. That's all they would have access to. So one, you can unplug that VPN appliance if it's vulnerable, but two, if you have to do a second form of authentication on that jump server to kind of a local Active Directory or local user database, unless you have knowledge of that, unless you've exfiltrated data from that network with usernames and passwords, you have to have that kind of authentication to get in. So it provides a layer of defense.
Interesting.
So here's kind of an example of a turbine control system. And there's a lot of terminology in here, so it's really going to be high level. But down here at the very bottom where we have the generator, this is actually kind of what we like to call the prime mover. This is what we're trying to control. This is typically a steam generator. And then to kind of control the flow of power into that generator, we have what are called actuators. And actuators are typically connected up to valves or something that's moving, typically the fuel. But they're usually non-intelligent devices. They're going to take their orders from a control system, which is what this 505 box here is. And this is a real-time operating system based control with a human machine interface actually on board. And it basically takes in I/O sensor information from these physical devices and uses them in calculating what needs to happen in the scheme of things. These other pieces of the puzzle, like this plant DCS, this is a distributed control system, so it may be controlling multiple systems like this turbine control system. We have a service tool where a field service guy may come in and adjust settings or provide updates. And then over here, we have kind of the electrical pieces of it. So we have some protective relay equipment. We have some grid synchronization equipment, basically in order to put power onto the plant grid. All these things talk together to figure out where that load is, when it's appropriate to actually put the power on the grid or the plant, and control the breakers and items like that. So it gets to be very complex very quickly. But all these things work together in a cyber physical system to provide power to either utility or a plant in typical application. This is an example of kind of the industrial control systems and critical infrastructure that I typically work on, that we typically work to secure. If you look at processes and other types of critical infrastructure or discrete manufacturing, you can replace a lot of this stuff with, you could probably get rid of the power generation type stuff, and you can really concentrate on your actuators and moving stuff around, if you will. There's a lot of other companies like Rockwell Automation, Siemens, Schneider Electric that kind of produce those types of PLCs, which stand for programmable logic controllers, that you can use to implement in your processes. So what are some of the threats to industrial control systems? Well, what's going to be an attacker's motivation? Usually it's going to, the top thing right now is getting access into an industrial control system or industrial OT network, extracting data, extracting intellectual property. Often designs are stored on some of these systems, even espionage. There were quite a few incidents in the last year of contractors for primes like Airbus and Boeing that were being hit by this type of data exfiltration on their industrial control networks, where it was just a ransomware, or not ransomware, but malware that was used to just lift designs off of PLCs or CAD, CAM type stuff that was actually in the OT side that didn't have all the security that the IT side would have. Other motivation is disruption of the process. Stop making items, stop making things, making money, which is kind of the ransomware efforts, and then hacktivism. If you're a hacker, if you're with a group of hacker or what's called a collective, and you have a political agenda, you may target an industrial control system for something that you're against. And then when we talk about attacker resource level, so as a defender of industrial control systems, I'm concerned about the motivation. I'm also concerned about the resource level, because that's going to kind of set up how much am I going to protect an industrial control system. And we kind of break it up into low-level hobby type hackers, script kiddies or people that have don't have access to a lot of resources. They can compromise using knowledge that's freely available on the internet, or they're just kind of doing this for fun. In the kind of the medium area, we have these advanced persistent threat. We have hacktivists group. They're a little more well-resourced attackers. They're also their motivation level is a little bit higher too. So they're definitely a threat to look out for. And finally, the people that you don't want targeting or you don't want to defend against are those nation state sponsored attackers. The people that have high amount of resources, they have armies of hackers that are researching issues or researching ways to get into systems. And they're just difficult to defend against if not impossible sometimes.
So, on that one, sorry to
Yep.
interrupt, but you know, Woodward sells, products worldwide. You, you sell a system to, one of these, say states or whatever, don't they have access then to be able to learn more, just by having the product in hand and having the software in hand?
They do, but often the devices that Woodward sells are also impacted by export control lists. So, from you can't sell direct to some of those folks. There's probably brokers or people that can grab some of this stuff kind of off the street, if you will. That's always kind of a threat, but it's it's definitely a consideration. I mean, reverse engineering is something you have to put into your threat model when you're designing a product about how to prevent some of that stuff from happening. And if you look at kind of the current market out there, we're starting to see the start of products that have had security built from the beginning, which have the capability to be resistant to some of that reverse engineering stuff. But the vast majority of industrial control systems out in the field right now are still that legacy.
Right.
Security wasn't even considered. So
Right.
there is always that threat. Yes.
Yeah. Interesting, because again, they've got, the resources to be able to go out and actually,
Yep.
Acquire this stuff and like you say, try and reverse engineer it.
Yep. That's very true. So yeah, so great question. Again, kind of with that impact, we're talking about like production stoppage, which, if the lines aren't moving, you're not making money. A financial loss, so you're not making a lot of money, you're losing money, and also kind of a loss of view. So a lot of the times when we attack industrial control systems, we're going to lose how the process is running, and unless you have actually properly architected your control system, you may not be able to shut down safely, without a human machine interface or a view. You don't have an emergency stop button. You wired that into the touch screen that is now gone. So you have to do a uncontrolled shutdown, which can usually be quite expensive in the repair bill. So I think those are some of the big impacts we have. Another side impact is changing a business relationship. If news gets out you've been hacked in an industrial control system, it could impact your relationship with upstream vendors, with downstream suppliers, with the media in general. It's usually called a helicopter event, where you have the news helicopter kind of floating around the business in your OT, and you don't really want to be the cause of that. So those are some of the impacts that can actually happen. But as we saw with Colonial Pipeline, one does not need to compromise an operational technology or ICS system in order to bring a company down. Often just compromising those key systems on the IT side is going to be enough. So when we talk about Colonial Pipeline, what was it? What was that event? It took place back early in May. It was a ransomware attack by the Dark Side threat group that attacked an IT system. So it attacked emails, files, enterprise systems, and we're going to revisit that here in a few minutes. What was the end result? It halted delivery of refined petroleum products like gasoline, aviation fuel, diesel in that pipeline. And that pipeline, I believe, was handling 70-some% of that product for the East Coast. And it was quite extensive. It went from Texas all the way into New England. When this initially hit, the operational technology side was really kind of deactivated or shut down, really out of an abundance of caution. They didn't know or didn't have insight if the ransomware had migrated from the IT side over to the OT side. But as Paul Harvey used to say, the rest of the story. What we know was the Dark Side threat actor who was based in Russia as a ransomware group. What was the attack vector? It ended up being a compromised username and password. That compromised the IT system. The product delivery stopped, not because the IT side was necessarily shut down. They were able to bring that up relatively quickly, but the billing system that monitored the product being delivered and billed the end customers was impacted by the ransomware. So there was no way to bill the end customer for the product, and they just couldn't move product because they had no analog or paper backup to handle that billing. They had all moved over to kind of a digital area. In order to kind of restore systems in a relatively short amount of time, Colonial Pipeline ended up paying a $4 million plus ransom to decrypt their systems. So that's kind of what happened with Colonial Pipeline. I think it was very interesting, and I think also really felt that it showed kind of a new threat vector for a lot of attackers against our IT systems, that they don't have to get into industrial control systems. They can just hack an IT system, and the control system will just follow suit. So that was kind of that IT or the Colonial Pipeline attack. So when we want to secure industrial control systems, I mentioned defense in depth. I mentioned kind of layers of security. Defense in depth in industrial control system is key. And what defense in depth really means is it's layers of defense that are overlapping and are heterogeneous, meaning you don't have the same type of defense in multiple depth levels. So you could have one type or one brand of router in one layer, and then another family in another layer, so that one system is not going to be compromised by another. That's the Cadillac method. Obviously, funding and budget always comes into play. So the more depth, the more different types of brands of stuff you can get in to protect, the better your defensive posture is going to be in the long run. Situational awareness. And this is just kind of outside your industrial control system. What is on my network? What assets do I have in my network that I know about, that I can detect? Do I have to do a physical walk down of the network to figure out what exactly I'm trying to protect or deal with? Am I a target? Is my company personally a target? And the answer will be yes. Just assume that you are a target. But how big of a target? Like, who's going to be attacking me? What kind of resources do they have? Well, that kind of depends. It kind of depends on your feeling for the day. Defend really against how big your threat is that you conceptually have. If you think a script kiddie, or if you think a hobbyist is kind of going to be your biggest threat, you can defend against that. Just don't expect any miracles to happen if someone who's heavily resourced comes in and tries to take over your system. Process monitoring. So industrial control systems, we're controlling a cyber physical process. We want to make sure that process being impacted, is a process still running smoothly. And I think this is a big thing that if you look at securing, and if you pay attention and focus to the process, and make sure that there's ways to safely shut down the process, to view if the process is running without a human machine interface, without a historian, making sure that it runs in its own little I want to say island, but resilient area, you're able to keep that product moving. You're able to shut down safely, saving money hopefully, or preventing a catastrophic failure. Network monitoring. Is there something unusual? So this is interesting, because one of the items we're going to talk about here in a couple slides is really around SolarWinds. And SolarWinds was a supply chain hack that we talked about earlier. The SolarWinds Orion product that was subject to that attack is network performance monitoring software, and it was actually kind of the fox in the hen house, if you will, in that attack, from the standpoint that it was monitoring everything going on in the network, including user credentials and keys, which caused a compromise of the system, and was able to get someone in there to basically get a whole bunch of usernames and passwords out into the dark web that people can use to access other systems. But network monitoring itself as a tool, you can identify if there's some unusual traffic that's taking place, especially in industrial control systems. They're not going to be connected to the internet unless you're like doing IoT or other types of stuff. But even then, you're going to have dedicated server IP addresses. You're going to know the route of the data. You know what's going in and what's going out. Network monitoring helps you detect, is there something unusual? Is it going to trying to hit some command and control server that, that you don't have on your network? Is there some traffic going between two systems that may be indicative of, malware being passed or encryption or exfiltration of data? So network monitoring is a really good tool to have if it's secure. And then finally, operational engineering. Are cyber threats actually impacting the process? Are systems properly segmented? Meaning that if we have segmentation, that if one system goes down, another system can still stay up. And that includes IT and OT segmentation. But do threats actually impact the process? Are any of the threats that we're trying to defend against actually impacting the process that we're trying to control? So those are some of the items you have to kind of consider when we talk about operational engineering and how we defend against those types of security issues.
So when you look at this list, I mean, this is obviously a global issue, and people who view this later or whatever, when you look at a smaller mid-sized business, kind of what are the tools that they're going to use versus kind of the really big companies? What are the tools that they're going to use?
The best tool out of this list that you can have if you're a small mid-sized business is the system segmentation. It's typically cheap. You don't have to have network wizards to implement this. It's really simply looking at your critical systems, evaluating what they are, and then making sure they're properly segmented so that only critical data flows kind of get back in and out. The other piece of that is defense in depth strategies. And one of the things you can do as a small mid-sized business is really, take a look at that Purdue model, classify your systems, get your asset management in place, but have a business continuity plan as part of your defense in depth strategy. And that's basically, going back to the basics around backups, going back to the basics around offsite backups, and practicing some of those items so that if you do get hit by ransomware, you have a good set of backups to restore your business continuity without having to pay ransom. So those are some of the small things you can do from a small, medium-sized business.
And again, these are companies around the world, and they can use those same techniques, right?
Right. Yep. Yeah. The IP network is pretty global. Industrial control systems and IT network systems are also pretty global. But yeah, they can definitely use those techniques.
Cool.
The other thing not to overlook is what is on my network. I think that doesn't necessarily need a fancy tool to pull off, what kind of devices you have around you. A simple walk down of your office or a simple walk down of your factory floor can give you a treasure trove of information that enables you to basically kind of know what you have in the network and kind of where it's expected to communicate to.
Thanks.
So I kind of touched on the supply chain category, and this is really kind of the supply chain snake, as I like to call it. And if you look at the supply chain from cradle to grave, you're seeing, it can get really overwhelming. But from a cyber physical systems producer standpoint, the supply chain really kind of starts off here on our left, where we have sourcing, assembly, packaging, and distribution. This is where we may have hardware type compromises that may take place, threats that are coming from our actual suppliers that we use for components inside systems. So we have to put some kind of security and assurance around that. In our production areas, and this is kind of the OT areas, assembly, where we can have insider threats, someone putting in code where they're not supposed to put code, falsifying program and test reports, hardware theft. You kind of brought that up. Someone could steal some hardware and then reverse engineer it. So we have those kinds of areas in production that we have to secure in that supply chain. And then we get into development and fielded systems. And this is where we have this life cycle cycle of patches and stuff like that. I mentioned SolarWinds earlier, and it's in this development and fielded system area where the SolarWinds compromise actually took place. Threat actors were able to get into the SolarWinds build infrastructure and actually insert source code in their repositories that then went into the build system, was signed and tested, and then shipped out as an update to several thousand fielded systems. And people installed it. They ran it through their own testing on those sites. And the particular SolarWinds vulnerability had a delay in it of like 2 weeks. So unless you were testing that system, that update for 2 weeks, you would not have known that it was going to start doing the SolarWinds hack, as they like to call it, or Sunburst hack is what it was called. So that's kind of an example, a high level view of where things can actually be exploited in today's supply chain. Any questions about that?
So that had to be fairly sophisticated to be able to get
Yes.
all the way
Yep.
back into the, the software of the product itself that's shipping.
It was sophisticated, but it wasn't sophisticated because the SolarWinds compromise was again another bad case of username passwords being exploited, and it was compromised username password that was able to get into that system, allow the threat actors to move laterally, put that source code in, and basically they were able to take a legitimate username password that was actively doing development stuff and just insert the code in that build environment, and then just sit back and watch and see what happens.
Right.
Yeah, when we talk about supply chain compromise, it does get into that nation state resource level to actually take advantage of that. However, there's also simple compromises that have happened with what are called watering hole attacks, where someone may put like a legitimate looking driver on a website for download. People will go there and download some malware that they don't know about. So it really kind of depends on the threat actor you're dealing with. So a little bit deeper on the supply chain, and this is from a vendor perspective. One of the things that we're really starting to see is hardware assurance, and people have heard about the chip shortages that have taken place around globally around the world with foundries and stuff like that. Well, what's happened in kind of the chip technology area, we have what are called SoCs, systems on a chip, which are really chips that are built up of a bunch of different processors and designs that operate as a system. And inside that system, there's actually firmware that makes it look like kind of a computer, if you will. So when you start getting into SoCs, you have to look at the firmware that was used to power those SoCs and make sure there aren't any vulnerabilities inside them. In addition, counterfeit issues with hardware assurance are proliferating at a rapid rate just because of the hardware shortages. People are trying to find chips any way they can. Counterfeit chips may show up in your supply chain. Another good incident or another good example of a hardware issue is Meltdown Spectre. That was a big issue with Intel chips. It still is a big issue with Intel chips, where speculative execution that makes our computers run so much faster nowadays could actually use to extract data from a computer. Another example of a hardware issue is the Apple M1 chip. There's a vulnerability in that chip that allows 2 sessions to do what's called a secret channel, and they could be malicious sessions or malicious applications that are talking in the background behind the security features of that chip. When we get into software, I'm a software developer. My favorite phrase is software fixes everything. Usually we have to fix whatever's wrong in hardware 9 times out of 10. But software assurance, we have third-party and open source libraries. And this is where we have purchased libraries and we buy it from a commercial source. We use open source libraries from the web, and there's vulnerabilities or Trojans that could be implanted in those pieces of software that we have to be aware of. So we have to put in some strong software assurance features in our supply chain in order to counteract that. In our own development environment, we kind of use what's called secure development lifecycle. And this is basically a set of practices around security requirements, security management, patching, and defect triage that really make up how a modern product with security in mind is developed. And flowing that down to suppliers from a software perspective helps us make sure that the software that we put into controls and systems is actually secure and is going to do what they say it's going to do.
So when you get into that third party and open source libraries, you know, there's a thought out there that, you know, the open source, you know, you have so many eyes around the world globally looking at that particular code that, you know, it sometimes can be actually safer than some of this closed source stuff. Is that an opinion that's out there shared with you know, the security guys?
It is, and it's a valid opinion, and it's you know, it's one of the benefits of having open source. And you look at some of the open source library vulnerabilities that we've seen in the last year with OpenSSL, OpenSSH, they get fixed relatively quickly. There's also the downside to that where everyone has access to the code so they can figure out ways to compromise that code faster. So there's a whole tool set that's now popped up around these kinds of this software question about components and stuff like that, and it's around software composition analysis. It's around binary analysis of binaries and looking for patterns of vulnerable code or vulnerable libraries. So you know, there's tool sets you can actually implement to scan some of this stuff. As a developer, and end users probably won't use it nearly as much, but you're also seeing kind of an industry perspective here. More people are trying to get control over open source usage, and you're starting to see more flow down of what were open source licensing policies from prime contractors or OEMs to suppliers on exactly what licenses they can use in their products.
Interesting.
So yeah, so examples on the in the software supply chain. Talk about SolarWinds Orion. You know, this is some of that. This is that information about that. You know, malicious code was inserted into the Orion software or Orion build system. The attackers basically took advantage of that build environment, and when the software was developed from source code, it was put in an executable package, signed, and delivered as an update. And the Orion network performance device really, you know, monitored any traffic, you know, user credentials, it had all that information to them, and that data was exfiltrated to attackers. A couple other examples, Amnesia 33 is an example of open source software that we kind of just talked about, but it was some projects that are used quite a bit in embedded systems and SOCs, which really handle what the IP network layer, the foundational networking layer around components. So this is kind of what enables you to communicate over the internet. But these were vulnerabilities that they identified that really was found to you know, cause a potential compromise. Not necessarily remote code execution, but you could use it to your advantage to take over a system, chaining exploits or using other exploits in conjunction. And then Ripple 20 is a similar item, but instead of a open source TCP/IP stack, it's a purchase component from a company called Trek. It has an embedded IP stack which is used in embedded systems, and you know, this is actually kind of rippled literally into other suppliers that have used Trek in their embedded devices, being impacted by this set of vulnerabilities. And you know, as a supplier, when you look at those kinds of vulnerabilities, or as a manufacturer, when you're looking at those vulnerabilities, you're going to look at, you know, severity. Does it impact the system, and is it being exploited out in the public? And you know, that kind of stuff will dictate the priority you have in fixing and patching some of these items. Further on, you know, kind of additionally in the threats in the supply chain, category, Kaseya VSA, which was out in, that was their June and July vulnerability of the month. Kaseya is a tool that's used by managed service providers. So these are folks that manage a company's IT networks as what they do. It basically is a tool to monitor and remediate those types of networks. Like by remediate, we mean put patches on the networks. The initial attack actually impacted the Kaseya VSA product on-prem. So this wasn't a cloud-based attack. It was actually installed on-premise devices and stuff like that. This was only like 30 or 40 companies that were initially impacted. However, the ransomware attack actually impacted more like 1,000 to 1,500 organizations, because out of all those on-prem installations, they were connected to additional organizations that were being serviced by these managed service providers. So Revel actually ended up trying to get $5 million per site to decrypt those items. They offered up a universal decryptor key for $70 million. And this week, Kaseya announced that they have a universal decryptor key, although they're not too forthcoming in how they received it. So this was a supply chain attack where you had a supplied service, for IT management, get into your IT system and then basically ransomware your network. So that's an example of kind of what we're dealing with contemporary wise in a protection environment. Pulse Secure, this is another good example of this is a VPN device. This was impacted by that Amnesia 33, surprisingly or not, and actually impacted the Pulse Secure appliance. So they were able to install web shells, they were able to install vulnerable malware devices to allow access into those VPN systems. And then finally, Hafnium, and this is the wrong description for Hafnium, but Hafnium was a similar web shell attack on-premise Exchange servers that allowed access to your Exchange, Microsoft Exchange email system. So those are some. I mean, Hafnium is a good example of what we called a advanced screening or advanced threat program that Microsoft had, where attackers were part of that program, knew what kind of vulnerabilities were present in Exchange, and used that information to craft their own zero-day exploits, or exploits that didn't have a patch. And when we talk about patching, this kind of gives everyone a headache sometimes. But back in our operational technology area, we often have to patch up here, and these are typically the HMIs that are in a control room, the ones that are controlling the system. And it's usually a manual process. There's sometimes automated patching that you can do. But then we also have to patch kind of the back office systems that are used to monitor the process. And if we really want to patch and have a lot of fun, we want to actually patch turbine units, or units that are actually out in the field monitoring devices. And finally, we can't forget about our distributed control system controlling everything, because we have to patch whatever is being controlled over there as well. So finally, security standards. When you have a security professional talk to you about what standards they comply to, or what standards you may have to comply to, this is a really short list, but these are probably the most common I find in cyber physical systems and industrial control systems. So as an end user, customers in the bulk electric system are going to comply to NERC CIP. If you deal with the Department of Defense or government, you'll be familiar with the NIST SP 800 risk management framework. If you're dealing with the government and other applications, such as pipelines and maybe the financial sector, you've got the NIST cybersecurity framework, the CSF. If you're doing industrial control systems, it's IEC 62443. And if you're just doing stock information security on your IT side, ISO 27001 is that information standard. Now, as a vendor for cyber physical systems, this is what I kind of have to develop my products towards. For industrial side, it's 62443. For the DoD, it's that NIST risk management framework. For any information revolving around products that are developed for the DoD, there's the NIST SP 800-171/CMMC standard, which is, so CMMC is the Cybersecurity Maturity Model Certification. That is a up and coming information protection standard that if you do any dealings with the government, you may have to, it'll be flowed down to you through contracts. It's just getting spun up now. Finally, we have ISO 21434, which is an automotive cybersecurity standard, and then DO 326A, which is an aerospace security standard. There will not be a quiz at the end, but if you want to sound smart in information circles, rattle off some of those standards and watch your vendors run for the hills. So that is it for my presentation. Any questions?
Wow, that was great, Chris. I don't have any, I was interjecting all the way through. I don't have any extra questions. Brian, you got anything there?
Something that's kind of new to me is a lot of deception technology seems to be popping up out there. And I'm wondering, I don't know much about industrial control systems.
Right.
So is that something that has been utilized or can be utilized?
Yep.
In this space too?
Yeah. Deception technology, otherwise known as honeypots, can definitely be utilized in the industrial control space, and it's pretty popular actually. There's kind of a niche market available to do that. What's interesting is there's a program out there called Shodan, SHODAN, which is what they call the Google for industrial control systems, and basically it crawls the internet and finds control systems are available on the internet that you can access or just basically ping and stuff like that. The deception technology is actually kind of cool because it will mimic those types of installations, like it'll mimic a PLC, like a device, and see if an attacker will actually start attacking it or tracing, where that attacker is coming from.
What about segmenting part of the network on the cloud? I mean, is that something that can help with adding additional layers of control with this too, or is it not allowed in most of these environments?
It depends. It a lot of the time depends on what your threat level is or what you're trying to control or work with. A lot of times cloud is kind of one way. They're gonna take data from the industrial control system and send it out to the cloud for analytics. Sometimes, depending on where you're at in your maturity or your application, you may take control input from the cloud as well. But that's really kind of, it's not the norm yet. It's starting to get some traction. People are starting to look at it. And one of the cool things about that kind of technology is you could make it more secure than it is today. So there's techniques in there around public key infrastructure, securing technology using network overlays and stuff like that could actually help you define what your security risk is around some of that stuff.
Interesting. Great talk, Chris. Thanks. Appreciate it.
I found it interesting that you were talking just briefly about open source. And I've always thought open source was something that was probably safer. And now after listening to you, it almost seems like it's not safer because people can access it so easily, and people could put something in there that if you're using open source software, you don't know what's in it, and you can just trust it because it's an open source software.
Yep. And that's actually a good point, Todd, because recently there were some examples of security researchers planting vulnerabilities in open source repositories or open source projects and watching them proliferate. Of course, open source project managers don't like that and will probably ban you from contributing if you do that in the future. But it was interesting to see just how fast, some of that code would proliferate. And that was a security researcher. So if someone was doing this on the sly, what kind of impact is that going to have?
Right.
And that's really where we start looking at open source analysis, using tools to kind of vet and verify what open source package you're using, making sure it came from a trusted resource, making sure that there aren't any known vulnerabilities, and then also you can augment that with security code scanning as well. So you can do static analysis on it. You can do some process around it to do like a security review, make sure that code is legitimate when you onboard it for your purposes.
So part of the reason that code was actually allowed was because they were a trusted source, right? They were coming from a university. Everybody said, "Oh yeah, should be fine. Let's let it rip."
Right.
And they were doing it on purpose as a research to see whether this bad code could proliferate. And so huge controversy, probably 4 months ago or something like that, trying to ferret out, was that the end of open source, period, right? Was that, really, was it the death knell for open source, or was it,
Well, I think it actually improved open source's chances, Ken. And I say that because it got a lot of people thinking of software governance and governance policies that they need to have as from a development or a corporate standpoint when you start using some of this stuff. And before then, unless you were an active contributor to like open source, maybe you didn't think about a governance policy as kind of your day-to-day. Now, if you use like dashboards or like SharePoint and stuff like that, and have open source components, you kind of want to have a governance policy around how that's being used and how that's being onboarded in your company.
Yeah. So excellent talk, Chris. I think we've gone a little bit over, taking up a little bit more of your evening, but I for one appreciate you coming in today and talking to us about this. This is obviously a pertinent discussion right now for companies and around the world. So appreciate it.
No problem. My pleasure. Always great to talk and kind of explain this a little bit more to those that need it. So again, connect up with me on LinkedIn or Twitter. Kind of follow me. It's a little bit eclectic sometimes, but it's definitely a fun cyber physical ride.
Excellent.
Yeah, thank you for coming on, Chris. You're very well spoken and very knowledgeable. It was very enjoyable to listen to you speak.
Thanks, Lauren.